Welcome. 2.3, the remainder and factor. Let's start out by doing some factoring and some long division of polynomials, all right? So that's how we're going to be able to, so we're assuming this right here is a factor. I'm telling you right now it is, but we're going to go through it together. So 2x minus 4 divided by 6, other way around, 6x to the third minus 2x squared minus 16x minus 8 divided by 2x minus 4. Let me zoom in a little bit. Cool. Now, the process, which I think you've all done this before, but we'll go through the process. What times 2x gets you 6x to the third? So let's start with the number. What times 2 gets you 6? It's 3. Then what times x gets you x to the third? It's x squared. So 3x squared. I'm going to multiply 3x squared to both terms. 6x to the third minus 12x squared. What I like to do, just to help me with signs, is I'll put that in parentheses and subtract. And then I think of it as this minus this, which should, your first term should always be 0. Okay, next term on the other hand, negative 2 minus negative 12. That's going to get you 10. 10x squared. Bring down our friends, 16, negative 16x and minus 8. And now we're saying what times 2x gets you 10x squared? Well, what times 2 gets you 10? 5. What times x gets you x squared? X. Multiply them, you get 10x squared minus 20x. Subtract, you get 4x. Bring down a negative 8. Now, what times 2x gets you 4x? Simple as that. It's 2. 2 times 2x is 4x. And then 2 times negative 4 is negative 8. Hooray, you get 0. It is a factor, okay? So 2x minus 4 is a factor, and once you factor completely. So we're at the point now we can simply do our AC method to finish factoring. AC method, so A times C is 6 in this case. What factors of 6 add up to 5x? That will be 3 and 2. So I'm going to substitute in 3x plus 2x plus 2, group, and then factor out of 3x plus 1, and factor out of 2, x plus 1. Hey, they match up to both x plus 1, so we can factor out the x plus 1, and then 3x plus 2. So when we factor the polynomial completely, it's this times 2x minus 4. Those are all your factors. You factor completely. Good job. Alright, this is the polynomial division rule. If we have f of x divided by d of x, that's going to be equal to whatever your quotient is. And at the end, we're going to put our remainder, whatever our remainder is, divided by d of x. D of x being what you're dividing by. This will be the proper notation whenever we don't have, or when we do have a remainder. If your remainder is 0, then just roll with this, or with q of x. It's perfectly fine. Let's do some. So, by using long division. So we set it up, and then what times x gets you negative 3x cubed? Will be negative 3x squared. So multiply that out. Negative 3x squared times negative 5x, negative 5x, negative 5 will get you 15x squared. Subtract. Bye-bye. Then going to get you negative 14x squared. Or put parentheses around and subtract. Okay? That's the easiest way to go about it. Bring down our friends. What times x gets you negative 14x squared? It will be negative 14x. Negative 14x squared plus 70x. Subtract, we get negative 66x. And what times x gets you negative 66x? It will be negative 66. Then multiply the negative 66 to the x and the negative 5, and we're going to subtract. we're going to get a pretty big remainder here. That's going to come out to be negative 396. Cool. So final answer when we write it, I'm going to use a different color just so it's distinguished. Negative 3x squared minus 14x minus 66 plus, we're going to do minus, we'll do minus since it is negative, minus 396 over x minus 5. There's your final answer for that one. Next one, let's set it up. So let's set up. What times 3x cubed will get us 6x to the 5th? That will be a 2x squared. Multiply it out. 6x to the 5th. Remember, you're adding powers. Whenever you multiply the same base, you're adding the powers. And it's going to get us negative 4x to the 4th. And then that's going to get us 2x to the 3rd. Now, keep in mind, I do not do this, but normally a good practice, anytime we are skipping a value, like when I mean by skipping a value is you see how we don't have an x to the 3rd? It's good practice to put in a 0 there as a 0 placeholder. So now I'm doing 0 minus that 2x to the 3rd. I subtract. So these go away. I subtract. I'm going to get 3x to the 4th. And then 0 minus 2 is going to get us negative 2x to the 3rd plus 12x squared plus 15x. What times 3x cubed gets us 3x to the 4th is just x, so add x. 3x to the 4th minus 2x to the 3rd plus x squared. This is going to come out decently. I get to eliminate 2 and 1. Lucky us. Subtract, get 11x squared plus 15x. We can't do any more because nothing times 3x to the 3rd will get us 11x squared, so we're done. Write our answer once again a different color. Let's use lime green, and then we got 2x squared plus x plus 11x squared plus 15x, that's our remainder, over 3x cubed minus 2x squared plus x. All right, synthetic division time. Who's excited? I am. Some people will be synthetic division people. Some people are long division people. It's good to do both because, honestly, my opinion, synthetic is slightly easier. Okay, but we can't do synthetic for everything, right? You need to be dividing by a linear function in order to do it. So let's do it. So whatever goes in our little box to the side is the value that makes this 0. Think of it that way. So what value makes it 0? It's a 3. Now let's do all of your coefficients. 4, 3, negative 1, 8. Once again, if you skip a value, you need a placeholder for this for sure. So you need to put a 0 down if we skip. If we went from x cubed to x without an x squared, we put a 0 there. All right. So 4, 3, negative 1, 8. I should give myself a little more space. Let's give myself a little more space. There we go. It's better. So you always bring down the first term straight down. Okay. Then whatever is down here below the line, you multiply by what's in the box. What's in the box? 12. That's not what's in the box. It's box. It says 3, so 3 times 4 is 12. Add them up, get 15. Multiply again, you get 45. Add, you get 44. 44 times 3 will get you 132. Add it, you're going to get 140. So what does this mean? So this is the part where people get tripped up on all the time, and it makes me sad. Okay, work right to left. Okay, first number is always your remainder. So we have a remainder of 140. So it's going to be 140 over x minus 3 because that's how we write our remainders in this class. The number after that is your constant. It's a constant of 44. Okay. The next number would be x. It'll go in order. Remainder, constant, x squared, x cubed, until you run out of numbers. Okay, every time. 15x and then 4x squared. We did it. Factor theorem is a nifty little rule we have here, all right? So if we're dividing by x minus c, it's a factor of the polynomial if whatever this number is right here, that c value, if you plug it into the function and it's 0, we know it's a factor, okay? Let's do an example together. Let's go down here. Trying to say, use the factor theorem to determine if the binomials given are factors of f of x. Use the binomials that are factors to write a factored form of f of x. So let's do it. So let's try x minus 6 first, okay? So if we plug in 6 into the function, f of, oh, marker's not working. Now it should. Yeah. F of 6. You plug 6 in everywhere into this function, what's your output? Your output would be 0. So it is a factor. I'll take care of factoring x minus 6 out in a minute, and then let's do 3 first. So if we put 3 in, what's your output? That's also going to be 0. So hooray, we have 2 factors, okay? So make sure you're able to plug it in. We plugged in, we had input and output values in the first chapter, so hopefully you remember how to do that. And of course, back in your Algebra 1 and Algebra 2 days. So let's do syntactic division in order to factor it out, because that'll be probably the easiest, right? So let's put 6 in. Bring down the 4. 4 times 6 is 24. Add, get negative 10. Negative 60. Add, get negative 6. 6 times negative 6 is negative 36. And good, because we need that remainder to be 0, right? So your new, or else it wasn't really a factor, or we did something wrong. So we end up with 4x squared minus 10x minus 6. Now we can do, now here's where people tend to make a mistake. They want to use these numbers again for x minus 3. Don't, okay? We want to factor our original polynomial completely. We did it once, and now we got 4x squared minus 10x minus 10. Now let's do the same thing with x minus 3. So we put 3 in the box. Use 4, use negative 10, use negative 6. Bring down the 4. 12. Add up to get 2. 2 times 3 is 6. Add up to get 0. So that our factor theorem still worked once again. We're left with 4x plus 2. We can factor that a little bit more, really, because GCF's 2. So our final answer is going to be 2 parentheses 2x plus 1 times x minus 6 times x minus 3. All done. I appreciate you watching, and we'll see you in class. Bye-bye now.